Section 6.3, Exponential Functions. All right, first of all, we're going to talk about what an exponential function is. At the top there, it says a function that has a variable in an exponent is called an exponential function. Okay, so basically, an exponential function is a function in which the variable is in the power. Okay, so in this section, we will be studying exponential functions. Okay, the first thing we're going to do with these exponential functions is learn how to graph them by hand. Okay, so your exponential functions can get really complicated. So the ones that you will have to know how to graph by hand are simple exponential functions. Okay, so it says the simplest exponential functions are of the form f of x is equal to a to the x, where a is basically a number that's bigger than 0 and a cannot be 1. Okay, all right, so let me go up here and kind of detail that. Okay, so for graphical purposes, our functions will look like this. Okay, your exponential function will be some number raised to the x power. Okay, so as far as an exponential function goes, the reason this is an exponential function is because x is the variable and it's in the power. Okay, the number that you're raising x to, okay, this is called the base of your exponential function. So the base here would be a. A is going to be some number, okay, and then this is called the exponent or the power. Okay, so keep that in mind if you hear these terms base or exponent or power. Okay, so again, we're starting off with very simple exponential functions where you're basically going to have a number raised to the x power. Okay, all right, so let's take a look at this. Okay, so in example 1, it says for each function, construct a table of xy values and use the points found to sketch the graph of the function. Graph both functions on the grid given below. Then answer the questions that follow. Okay, so the first exponential function that we're going to try to graph is f of x is equal to 2 to the x power. And then secondly, we will graph g of x is equal to 1/2 raised to the x power. Okay, to do this, because you know this is our first experience in this class with exponential functions, remember when you don't know what something looks like, you need to make a table of values. Okay, all right, so let's see here. I'm going to start with 2 to the x. Okay, when you make a table of values, remember you're in charge of x. Okay, so you want to pick a variety of things for x. Okay, and then you'll take each x value, plug it into the function to get the y value, and then you'll have an xy pair to plot. Okay, all right, so here we go. I'm making my table here. Okay, so in this leftmost column, I am going to put x values. Okay, so like I said, I want to pick a variety of things. Okay, so I'm going to pick 0, and then I'm going to pick some positive things. Okay, and I'll pick a couple of negative things. Okay, so that should do. Okay, so these are my x values. I'm going to take each x value and I'm going to plug it in to the first equation I have here. So f of x, which is y, is equal to 2 to the x power. Okay, all right, I am going to start with the 0 here. Okay, so if x is 0, my y value is going to be 2 to the 0 power. Everywhere you see an x, you want to replace it with 0. Okay, so what is 2 to the 0 power? Well, we've talked about a 0 exponent before. Anything raised to the 0 power is going to equal 1. Okay, so the point is going to be 0, 1. If x is 0, the y value is 1. Okay, so our graph will go through that particular point. Okay, so now I'm going to plug in the positive x values. Okay, so if x is 1, that means the y value is going to be 2 to the first power, which is just 2. So if x is 1, the y value is 2. Okay, next I'm going to plug in x equals 2. Okay, so this is going to be y is going to be 2 raised to the second power, okay? 2 squared just means multiply 2 by itself twice, okay? So that's going to be 4. So if x is 2, y is 4, okay? Then I'll plug in x equals 3. So I'll get y equals 2 to the third power. That means you're going to take 2 and multiply it by itself 3 times. So 2 times 2 is 4 times 2 is 8. So if x is 3, y is 8. Okay, so that's good. We've got a lot of points. Okay, but now we're going to go and plug in some of the negative values to see what happens. Okay, so if x is negative 1, I'm going to get y equals 2 to the negative 1 power. Okay, well, you're probably like, well, what does that mean? Okay, here is what you do if you have a negative power. Okay, we don't think in terms of negative powers. They're very hard for us to process. Okay, so there is a procedure you can do to eliminate negative exponents. Okay, so this is what you do to get rid of this 2 to the negative 1. Okay, you're going to do 1 over it, 1 over the entire quantity, so 1 over 2 to the negative 1, and you're going to change the sign of the exponent. Okay, so this is going to become 1/2 or 0.5. Okay, that's what 2 to the negative 1 is. Okay, and if you're not sure, you can see it on the calculator. 2 raised to the negative 1 power is 0.5. Okay, but this is how you can do it by hand. Okay, so if x is negative 1, the y value is going to be 0.5. Okay, and now we're going to plug in negative 2. Okay, so we're going to get 2 raised to the negative 2 power. Again, it's hard for us to process negative exponents. So to eliminate it, you're going to do 1 over the quantity, change the sign of the exponent. So this is going to be 1 over 2 squared. So 1 over 4, which is 0.25. Okay, so again, you can see that 2 to the negative 2 power is 0.25. Okay, so basically our point here, if x is negative 2, the y value is going to be 0.25. Okay, so we've got several points to plot here. Okay, I will start with x equals 0. So at x equals 0, our point is 0, 1. And then we've got 1, 2. And then we've got 2, 4. And then we've got 3, 8, which is right here. And then I need to go for these negative x values. So if x is negative 1, the y value is 0.5, which is halfway between 0 and 1 on the y-axis. And then if x is negative 2, the y value is 0.25. Okay, so you can kind of see the picture of this graph coming together. We need to connect the dots. Okay, so I'm going to connect what I have here. Okay, so what's going to happen here, the graph, if you go to the right, it's going to keep climbing. Okay, so it's going to go up like that. Okay, and then what happens in this direction, okay, is that the graph gets closer and closer to the x-axis, but it never touches or crosses it. Okay, so think about it. If you had an x value of negative 10, so if you were way out here, okay, your y value would be 2 to the negative 10, which is 1 over 2 to the 10th power. That would be something positive, but it would be really tiny. It would be a small positive decimal. Okay, so you would be just above the x-axis. Okay, so this is the graph of f of x is equal to 2 to the x. Okay, this basic shape is what an exponential function looks like. You can expect one side to climb very, very quickly, and then you can expect the other side to level off somewhere. Okay, so obviously the right side here is the side that's growing quickly, and then the left side is leveling off at the x-axis. Okay, your graph won't necessarily level off at the x-axis, it's just going to level off somewhere. Okay. All right, so now we need to draw the graph of g of x. Okay, so we're going to make a table of values. I'm going to use the same x values. Okay, so I'm kind of out of room here, so I'm going to go to a separate sheet of paper to make my table. All right, here we go. I'm going to go to the next page, and I am going to make a table of values for g of x is equal to 1/2 raised to the x power. Okay, so over here, okay, I'm going to, let me get my table drawn. Okay, so again, we're in charge of the x values. Okay, I am actually going to choose pretty much the same x values from the first table. Okay, so I'm going to pick 0, I'm going to pick 1, 2, okay, and then I'm going to pick -1, -2, -3, okay. We're going to take each of these x values and plug into the function y equals 1/2 to the x power, okay. Again, I am going to start at x equals 0, okay. So here we go. We're going to get y equals 1/2 to the 0 power, okay. Anything to the 0 power is 1, so this graph will also go through the point 0, 1. Okay, next I'm going to plug in x equals 1, so this is going to be 1/2 to the first power. So you're multiplying 1/2 by itself one time, so you're just going to get 1/2 or 0.5. So if x is 1, the y value is 0.5. Okay, and then we're going to plug in 2 for x, so we're going to get y is equal to 1/2 squared. So that means you're multiplying 1/2 by itself. Okay, so to multiply fractions, you multiply across the top and you multiply across the bottom. So 1/2 squared is 0.25 or 1/4. So if x is 2, y is 0.25. Okay, going to the negative x values now, I'm going to first plug in x equals -1. So we're going to get that the y value is 1/2 to the -1 power. Okay, so let me show you how to simplify this by hand. So if you have a fraction raised to a power, you can raise the numerator to the power and the denominator to that power. Okay, then we're left with negative exponents. We don't like those. So to get rid of them, since we have a fraction, we're going to relocate to the opposite place in the fraction. Since 1 to the -1 is in the numerator, it's going to move to the denominator and we're going to change the sign of the exponent. And likewise, 2 to the -1's in the bottom, so we're going to move it to the top and change the sign of the exponent. So we're left with 2 to the first power over 1 to the first power, so you end up with 2. Okay, so basically if x is -1, the y value will be 2. Okay, you could go to your calculator, you could punch in you could punch in 1/2 raised to the -1 power, and out should come 2. Okay, all right, so now I'm going to plug in x equals -2. Okay, so we're going to get 1/2 raised to the -2 power. Okay, again, I'm going to raise the numerator to that power, the denominator to that power, and then I don't interpret negative exponents well, so we've got to switch places in our fraction here. Okay, so 1 to the -2 power, it's in the numerator, so we're going to move it to the denominator, change the sign. Okay, and then the 2 to the -2, it's in the denominator, move it to the numerator, change the sign of the exponent. So you're going to end up with 2 squared, which is 4, over 1 squared, which is 1. So this whole thing turns into 4. So if x is -2, y is 4. Okay, I'm out of room for 3, but I'll do it up here. Okay, so lastly, I'll plug in x equals -3. So we'll get y equals 1/2 to the -3 power. Okay, so raise the top to the -3 power, raise the bottom to the -3 power, eliminate the negative exponents. So we're going to move around in the fraction. 1 to the -3 will move from the top to the bottom, but we'll change the sign of the exponent. And then 2 to the -3 power will move from the bottom to the top, but we'll change the sign of the exponent. So we're going to end up with 2 cubed. That's 2 times 2 times 2, that's 8. Over 1 cubed, which is 1 times 1 times 1, that's 1. So you end up with 8. So if x is -3, y is 8. Okay, so we've got several points to plot. Okay, so I'm going to go back to my graph. I'm going to put this particular function in a different color. So let's see here. I'll make this one red. Okay, and then I have already put f of x in blue. So let me put that in blue so you can keep track of what is what. Okay, so let's plot our points here. Okay, so for g of x, it goes through 0, 1. Both functions go through 0, 1. Okay, and then we go through 1.5. Okay, so if x is 1, the y value is 0.5. And then we go through 2.25. That's going to be right here. And then we go through negative 1, 2. Okay, so that's going to be right here. And then negative 2, 4, which is right here. And then lastly, negative 3, 8. Okay, so you can see that this graph has basically the same sort of shape. Okay, but now if we connect the dots from left to right, okay, as we go to the right, we're getting closer and closer to the x-axis, but never touching it or crossing it. Okay, and then as we go to the left, that's where we're getting higher and higher and higher. Okay, so the red graph is g of x is equal to 1/2 raised to the x power. Okay, both of these are simple exponential functions. The x, the variable, is in the power. Okay, and the base is just a simple number. Okay, so now that we have the graphs here, we're going to answer some questions or fill in some information about these graphs below, and I will do that in the next video.